Good evening, all of you. Are you people able to hear me?
Yes, sir.
We are first supposed to deal with capacitors assignment, right? Let me share the screen with you people. This assignment we should discuss. कुछ तो बोलो.
Yes, sir.
Problem numbers. Joseph, you wrote 1-4. It means 1 and 4 or 1 to 4? That's all. 11. Now don't type to the host. Please on your mic and speak, because on my screen I have got the assignment. I don't have your screen here on the laptop. Now question number 1. Little bit of patience. I'll have to draw the circle. You have one capacitor here, one capacitor here, one capacitor here. Right? Now you connected a battery here, if I am right, with the positive polarity. Each of the capacitors is of capacitance C. Find the potential at O. Whenever they ask you such type of potentials, remember nodal analysis will be the safest. I explained this in the last class. Take this as X, yes, take this as Y, take this as 0, take this as V. This is 0. Right? Now I call this positive, negative. I call this positive, negative, positive, negative, connected to the positive terminal. Positive, negative, positive, negative, positive, negative, negative, positive, negative, positive. Agreed? Now observe this. Charge on these three plates are mutually connected and isolated. Do you agree with that?
Yes, sir.
Right? So now this is positive, right? This is a positive plate that you have taken.
Yes, sir.
I committed a mistake in the diagram. I don't have a capacitance here. Right? I copied
Yes,
the diagram wrong. I don't have a capacitance. That makes my life a bit simple. This will be 0 volts. Now, charge on this plate is plus Q. How much is that charge? Y minus 0, potential difference into C, plus or charge on this plate, Y minus X into C. Charge on this plate, minus of my minus V into C. Sum total should be 0. Are
yes,
you
sir.
convinced with the first equation?
Yes, sir.
Right? Now observe this. These 4 plates are mutually connected and isolated. Why do I need a second equation? Because there are 2 variables X and Y. I had no
Yes,
choice. Because you have a capacitor here. If you didn't have a capacitor here, this is V, this is V. One
yes,
equation, one variable, my problem would have been solved.
yes,
Now see, this plate, this plate, this plate, and this plate. Now you took positive charge here.
yes,
I committed one mistake here, you people didn't observe. Did you people see the mistake here? Negative charge ke liye I put negative sign. But
yes,
charge should be V minus Y. I committed a mistake here. Did you people observe this? V minus Y. V is at higher potential than Y. What makes you say that? Your assumption that this is positive charge.
yes, sir.
Right? Positive charge here, Y minus X. Positive charge here, Y minus 0. First equation. Second equation, oh, have a look at it. I have a negative charge here. Put a negative sign. But this is a greater potential than this. Y minus X into C.
Yes,
What
sir.
makes you say Y is greater than C? You assumed this is positive. No, this is positive charge. Plus or X is greater than 0. X minus 0 into C. What makes you say X is greater than 0? This side is positive. Same here. Plus of X minus 0 into C. Now here V is greater than X because this side is positive. Plus of V minus X into C is 0. I have 2 equations and 2 variables called X and Y. You will
Yes,
get
sir.
the answer.
Yes, sir.
Minus of V minus X.
Y negative sign, right? Fine. Negative charge, so minus of V minus X into C. 2 equations, 2 variables in terms of V.
Yes, sir. Done, sir.
Third, when the switch is open, have a look at it. You have one capacitor here, one capacitor here, one capacitor here. These both are connected. This C is connected to the capacitor C. This is V. When the switch is open, this capacitor is out of the circuit. Right? When the switch is open, technically, let me not draw this so that you'll be very clear about what's happening. Right? So, don't you think these 2 capacitors are short circuit? The charge which comes here, why will it flow through this branch? It will flow through this branch. So these both capacitors are short circuited. I've got only C here. So what is the energy? I'll call it U initial as half CV square. Now I have a capacitor here and I have connected it to this. Right? This is C and C. This is C. Now find out the C equivalent. C is 3 microfarads, B is 10 volts. Now find out the C equivalent. Have a look at it. You will have to rearrange them. Call them as A, B. No, call them as 1, 2, 3 something. 1, 2, 3, 4. Right? Now here, this is missing. But for that, it is almost a weak bridge. Do I have a capacitor here? No. When the switch is closed, can you tell me the C equivalent of this? U final is equal to half C equivalent into V square. Difference will be the work done. Right. Rearrange this. This is 1 and 2. Right. 2 and 3. You connected this. Now 1 is connected to 3. 1 is connected to 3. Now 3 and 4, you have one capacitor. 3 and 4. Right. 3 and 4. Now 2 and 4 ke beach also that's a capacitor. There is a capacitor between 2 and 4. Between 2 and 4. Now this should not be difficult, right? Between 1 and 4, you have got a battery. Between 1 and 4 implies this as a battery. Right? 4. Great. Now will you be able to solve? These both are in parallel. Yes or no? C and C are in parallel. Potential difference across this is equal. C and C in parallel is 2C. I will draw that 2C here. And I will draw the C here. I will draw the C here. Right? This point, 1 and 3 are at the same potential. I'll draw the battery here. Right? Between 4. This is 4 and 1. Now 2C and C are in series. That is in parallel with C. 2C and C are in series. 2C by 3 plus of C. 5C by 3. So C equivalent is 5C by 3. U final, U initial difference below, you will get the answer. The key catch in rearranging this, he's playing with you people when he is asking for the rearrangement. The moment you see this, you will not understand directly what is the equivalent circuit. Find these both to be in parallel, that is in series with this, thereby the job becomes easy. Clear up the board. The next problem is actually fourth problem, a tricky one. This is at 100 volts, if I am right.
Yes.
Right, initially switch is open, so I'm not worried about it. 2 microfarads, 1 microfarad. This is how much? 1 microfarad. This is 2 microfarads. Agreed? What will be the C equivalent of this? This will be positive, negative, positive, negative. Positive should be at higher potential, negative will be at lower potential. Right? What is the C equivalent for this? 2 by 3. What is the C equivalent for this? 2 by 3. So what will be the time potential difference across? This is also 100 across, this is also 100. So charge on this will be 200 by 3 microcoulombs, 200 by 3 microcoulombs, 200 by 3 microcoulombs, 200 by 3 microcoulombs.
Yes, sir.
Initially, this is the situation. Yes or no?
Yes, sir.
Now, I'll redraw the circuit. Are you able to see this part of the board?
Yeah, yes, sir.
Round this slightly to the left, but it's okay. I'll shorten the grounding and I'll draw it down. I'll have to bend a bit. You short circuited this, that means it became 0. Short circuited this capacitor. This will remain as 100 volts. This will remain positive, negative. This is 1 microfarad. This is 2 microfarads, 1 microfarad. Now this will remain positive, negative, positive, negative. Charge on this will remain 200 by 3 microcoulombs, 200 by 3 microcoulombs. This part will not change. All that we have done is short circuited this. This became 0. Now simple thing, have a look at it. How much will be the charge on this? This will become, what is the potential difference across this 100? This will become 100 microcoulombs. From 200 by 3, it will come down to 100.
Yes,
200
sir.
by 3 is how much?
66 something.
Point,
3.66.
right? Now, additional charge came here.
Yes, sir.
Look at this negative charge. Initially, this negative charge and this positive charge, these both were mutually connected and isolated. Was the charge on that 0?
Yes, sir.
Are you able to hear me?
Yes, sir. Yes, sir.
Right? Initially, this negative and positive plate put together, was the charge 0 or no?
Yes, sir.
Now, these two put together, I have minus 100.
Yes, sir.
It was 0. Now, this plate put together is minus 100. That means plus 100 microcoulombs should have gone through this particular part. Only then this will have minus 100 now.
Yes, sir.
So I found out Q1 or Q2, which one I don't know. The charge that flows through the switch is Q1. Charge that flows through the earth. Now you know how much charge flows through the earth. Have a look at it. Initially, this and this put together, what was the charge? Minus 200 by 3, minus 200 by 3, minus 400 by 3. Now
Yes.
I have minus 200 by 3. Right?
Yes, sir.
This is minus 200 by 3. This became 0. That means this minus 200 by 3 went into the ground, but the charge that went into the ground includes not only this minus 200 by 3, but also this 100.
Yes.
Now you know total charge which went into the ground
Yes, sir.
and the charge which went through the switch.
Yeah, yes, sir.
Will you be able to complete the problem?
Yes, yes, sir. Done, sir.
Of the board.
Sir, if we use equivalent capacitance and find out the total charge that has to be inside the circuit, it comes out to be 500 by 3, right, in this case? Because 2 by 3 plus 1 into 100
Okay.
And here we have 400 by 3 and 100, which is more than that, right?
Naturally, when you close the switch, additional charge came over here.
Yes, but after all, इस पूरे एलिमेंट के अंदर या इस सिस्टम के अंदर होना तो इन तीनों कैपेसिटर्स का मिला के 500 by 3 चाहिए ना?
Say that again.
Sir, when we take equivalent capacitance, we know the potential difference across the capacitors is 100. So the net
Right.
charge will be 500 by 3.
Hey, you're taking net charge, only one positive charge. Don't
No, I'm
isolate the
saying
plates.
नीचे वाले जो आपने डायग्राम बनाया है, yes, over here, if we let's say there was a 100-volt battery connected to the left of this, just for 1 second. Yes, there
Okay.
is a 100-volt source over here. So now,
Right.
the net entire charge on the capacitor system should have been 500 by 3, because 2 by 3 plus 1 is 5 by 3 and potential difference is 100.
Okay.
So in total, the splitting of the charges should also give us total charge as 500 by 3, right?
नहीं होगा, नहीं होगा, कभी मत करना. Please conserve the individual plate separately. You must be going wrong in the conservation of the charge on individual plate separately.
Oh no, I got it. I took
Equivalent
series में
मत
दो
लेना,
बार.
कभी भी नहीं लेना.
No,
He's
I got it.
asking you how much charge is flowing through this. Simple. This plate. What was the initial charge?
Yes, sir, I got it. 200.
Zero. Somewhere in the addition you must be going wrong. You must be missing
No,
one
I
of the plate.
understood, sir. I took series का दो बार. Like series में 200 by 3 charge आएगा, उसको मैंने दो बार ले लिया.
Fine. By the way, this will be the safest anytime. If he is connecting this plate ka initial charge, final charge. Difference. Because they are isolated.
Yes, sir, I got it.
Now the next was eighth problem. 1 second. Eighth problem may always remember the charges on the inner side only will produce a field. 20 volts. Charges here only. The charges here will give me zero field here. They don't contribute to the charge of the capacitor. Because of the charges on the outer side, you are storing no energy in the capacitor. So firstly, you are given 100 microfarads, 300 microcoulombs. 100 plus 300 is 400. By 2 is 200 microcoulombs, 200 microcoulombs. What was the charge here? Minus 100 and 100. So this was the charge distribution when the switch was open. Now that the switch is closed, potential difference across this should be 20. Potential difference will come because of the field in between. Field will come only because of the charges here. Right? So the potential difference here should be 20. How much is C given to you in this problem? 20 microfarads. 20 into 20 will be 400. So this will be 400. This will be minus 400. If I have taken the polarities right. I have committed one mistake in the question. Battery is shown wrong. Battery means they showed this as negative, this as positive. Implies the polarity shown diagram is wrong. Battery देखा है आपने? Battery, the positive plate is shown as negative. So it's a mistake. This should have been the situation. This is positive, negative. So this will be plus 400. This will be minus 400. Right? There is a mistake in the print. The right side will not be the longer line. Right side will be the shorter line. Now watch out for this. This should be plus 400. This should be minus 400. Agreed? What was the initial charge? Minus 100. It should rise to 400. That means how much positive charge should have been pushed? 500 microcoulombs of positive charge should have been pushed. Amount of heat produced in the circuit. Now you do work done by the battery. You know delta U plus heat loss. Work done by the battery 500 into 20 microjoules. Delta U, initial energy, U initial is 100 square by 2C. U final is 400 square by 2C. Polarity of the battery is a very crucial thing here, right? What made you say that this is positive and negative? Because I saw even the capacitor. On the capacitor also he showed you this positive and this negative. So I took this to be positive. It's a misprint as far as the battery terminals is concerned. Delta U, you substitute here, you'll get work done by the batteries delta U plus heat loss. Can I rub the board? Are you people able to see me?
Yes, sir.
The screen has gone blank. Okay. No, are you able to hear me?
Yes, sir.
Now are you able to hear me?
Yes, sir. Yes, sir.
Okay. Now, as far as the 11th question is concerned, they're playing with you people. They gave you C4, C1, C2, C3. Right? They are telling you breakdown voltages. That means if C1's breakdown voltage is 60, it cannot have a potential greater than 60. The moment you apply a potential greater than 60, C1 will break down. This is the language to be understood. Yes or no? Say something.
Yes, sir.
Right? Now, if this is V, what will be the potential across this? V.
So
This will be V by 2. Why will that be V by 2? Because you gave this as 1 microfarad, this as 2 microfarad, this as 3 microfarad. 1 plus 2 is how much?
3.
Wonderful. So this is V by 2, this will be V by 2. V by 2 is the potential across both of them. So case 1, for breakdown at C1, V by 2 should be greater than or equal to 60 volts. Did he give you 60 volts? Right? So V greater than or equal to 120 volts, C1 will break down. C2, V by 2 greater than or equal to, कितना दिया है C2 का?
50.
50. Wonderful. He's verifying if we multiply properly. 100 volts. When V is 100 volts, this will break down. V by 2 greater than or equal to, C3 का
90.
breakdown कितना दिया है? 90. V greater than or equal to 180 volts, this will break down. V greater than or equal to C4 का कितना दिया है? 150 volts. Which is the least? The moment I cross 100 volts for this, first of all, ये किसके लिए? C2 के लिए, C3 के लिए?
C2.
C2. This will break down first. So the maximum voltage I can have to the circuit is not more than 100 volts. Am I right? If my calculation is correct. Cheap tricks, well played. Can I have the board?
Yes, sir.
Yes.
Assignment doubts over.
Sir, I had a doubt in question 6.
Question number
6.
6. Question number 6. This is the capacitor, battery, capacitor, battery, capacitor, battery, capacitor, capacitor, capacitor. Am I right?
Yes.
Initially, switch was open for a long time. All capacitors are 2 microfarads, 2 microfarads, 2 microfarads, 2 microfarads, 2 microfarads. Switch was open for a long time. And what is the battery having? Battery
10
kitna?
volts. 10 volts.
10 volts, 8 seconds. Where is this? Yeah. Battery is 10 volts. This is 10 volts. This is 10 volts. When the switch is open for a long time, start from here. This is 0 volts. This will be 10 volts. This will be 10 volts. What will be the potential here? I don't care. The switch is open. The potential here will be 20 volts. Am I right?
Yes.
Yes or no? Say something.
20.
Agreed. Switch was open. Switch was open. Charge on these two plates should remain constant. Charge on these two plates should remain constant. Yes or no?
Yes, sir.
When the switch is open, these two plates are mutually connected and isolated.
Hmm.
Agreed. So charge on this plate and this plate put together should be 0.
Yes.
Agreed.
Yes, sir.
Now watch out for it. I'll have to redraw the circuit once again. I hope this part of the board is visible. This part of the board is visible. Visible, right? Now this was 10 volts, 2 microfarad, 10 volts. Here I had a capacitor, 2 microfarad, 2 microfarad. This is 10 volts, 2 microfarad. Right? Now that the switch is closed, again this is 0 volts, this is 10 volts. This is 10 volts. This will be 20 volts, this will be 20 volts, this will be 20 volts. Right?
Right.
So now your job is done. These both capacitances are in series.
Yes.
So 2 and 2 are in series. 1 by 2 plus 1 by 2 is 1. So this will be 1. Right? This is at higher potential. Positive, negative, positive, negative. 1 into potential difference is 10. This will be 10 microcoulombs and this will be 10 microcoulombs.
Yes.
Now watch out for this. Initially this and this was 0. Battery is neither a source nor a sink. Even now, this plate and this plate put together should be 0.
Yes.
If this is plus 10, this will be minus 10, positive. This is 10 microcoulombs, but with negative charge. Just a minute. This was 20. So this is 10, right? This was 20. So this will be 10 volts. 20 minus 10 is 10. 10 into 2. This will be 20 microcoulombs. Am I right? This
Yes.
is minus 20. So now listen. Small correction. Here these two plates are mutually connected and isolated. Now that the switch is closed, these two plates are not mutually connected and isolated. These two are connected by this. Initially switch was open. So this and this put together, initial charge was 0. Now this and this put together, initial charge, final charge is how much? This is plus 10, this is minus 20.
Minus.
Plus 10 minus 20. So minus 10. How much charge came through the switch? Minus 10 microcoulomb. Now you get this point clear. Initially,
and-
this plate put together is 0. Now this plate and this plate put together is not 0 because you closed the switch.
Hmm. So then it does not depend on the initial charges on both of them, right? Which are isolated.
It does depend. Initially it was 0.
The total charge was 0, but
So
not
how
on
much charge came through this?
minus 2. Yeah. Got it.
Finally, both these plates put together is minus 10. So how much charge came through the switch? Minus 10.
Yeah.
Sir, can you explain how the charge was minus 10?
This is 0, 10, 10. This will be 20.
Yes, sir.
This will be 20.
Yes, sir.
This will be 10.
Yes, sir.
So potential difference is 20 minus 10.
Oh, yes, sir.
So 10 into 2 is 20 microcoulombs.
Yes,
So
sir.
the lower plate has minus 20 and here it is plus 10. Minus 20 plus 10. These both plates initially connected with 0 charge.
Yes.
Now they have minus 10. Where did the charge come from? From the switch.
Okay, okay, yes, sir.
Yes, sir. That's
Sir, I have a doubt in heating effect of a current, that assignment.
That we'll deal with later. Current electricity. पहले capacitors खत्म करें.
Okay.
HCV capacitors. Exercise से शुरू करें.
Sir, can you do booklet first? Yes, sir.
Booklet. I'll have to. एक second रुको. Booklet देखूंगा. If I get it on the system, well and good. If not, capacitors. You have downloaded it so many number of times that searching this is capacitors. Electrostatics currents. कुछ और निकल आया है. रुको. Capacitors booklet is coming. Wait a second. All of you okay if I deal with the booklet first?
Yes, sir.
Yeah. Capacitors. Then we go where? Booklet. Yeah. Tell me.
Sir, exercise 3, passage 3.
ये डायरेक्ट एक्सरसाइज 3 मत जाओ यार. एक्सरसाइज 3 पैसेज 3 मैं तुझे भेजूंगा. एक सेकंड. अभी ग्रुप में सॉल्यूशन भेज दे. एक्सरसाइज 3 पैसेज 3. फिर मेरी फ्लैगशिप 1 फ्लैगशिप 2 क्यों नहीं दिखाई दे रहा है? Send. Exercise 3 passage 3 के लिए जो लोग बैठे हुए, you don't need to wait for it. I sent the solution. Now tell me exercise 1.
The 33rd question.
33rd. Last problem बोला. No, listen. बोलते जाओ. 33rd. Okay, next. $29.
So 22.
22. Out of 22 participants, 2 participants are me. 20 candidates में some people don't have any doubts and बाकी लोग आए ही नहीं. ये flagship 1 and 2. No, listen. 22 is only labor. You will have to solve it. First of all, 33. 33, you have two large plates, P1 and P2. How much is the charge given? Charge of plus 2Q and minus Q. 2Q and minus Q are given. Am I right?
Sir,
Now, what is the charge distribution? 2Q minus Q is how much?
total charge is Q. On the outer source will be Q by 2, Q by 2.
Q by 2, Q by 2. This will be 3Q by 2 minus 3Q by 2. Can you tell me what is the initial energy? 3Q by 2 whole square by 2C. C is epsilon naught A by D. 3Q by 2 whole square by 2 times epsilon naught A by D. This is the initial energy. Now that you close the switch, then both of them delta V should become 0. Delta V becomes 0 means E into D should become 0. That means field should become 0. Here field becoming 0 implies these both should merge into each other. So U final will be 0. U initial is this. You know difference is lost in the form of V. Yes or no?
Yes, sir.
Now listen, as I understand from your situations, I don't see whole of the class having completed the homework. Our again next doubt lecture with you people will be again on Monday evening, Sarnapur. Because other batches come in Tuesday, Wednesday, Thursday laga. Friday I take some breathing space. Saturday, Sunday you people are loaded with exams and online lectures. So our next every week Monday evening 7 to 8 I will be there for doubts for your section exposure. But please channelize it and get it done. This is not the way. Exercise 1 में 3 problems बोल रहे हो. 1 or 2 students finished up to exercise 3. Some haven't done even exercise 1. This incoherence will be uncomfortable for you as well as me. You were given surplus time. 1 week of a time you were given. I asked you people last Tuesday. You people told me this Monday. Yet this is the state. Not acceptable. Highly unacceptable situation. This problem, is it clear?
Sir,
29. See, 29th mein you have one capacitor here, one capacitor here. You connect this to a battery. The diagram is hopelessly bad. Battery they showed with a box. That shouldn't have been the case. Two identical capacitors, 1 and 2, are connected in series to a battery as shown in the figure. Capacitor 2 contains a dielectric slab or dielectric constant K as shown. This has a dielectric constant. This is C2 and this is C1. Q1 and Q2 are the charges stored in the capacitor. Q1 and Q2. Obviously, Q1 is equal to Q2 simply because you have a dielectric here. अरे भाई इसका capacitance कुछ भी हो सकता है. C1 and C2 even if they are not equal, Q1 will be equal to Q2 as they are in series. Right? They are just playing with you people. Q1 is equal to Q2. Now what will you do? Now the dielectric slab is removed and the corresponding charges are Q1 dash and Q2 dash. Now again, by the way, Q is equal to how much? Q1 is equal to Q2 is equal to C equivalent into V. What is C equivalent? C1 C2 divided by C1 plus C2 into V. If this is C and this is K times C, this is K times C. C plus K times C into V. This is Q1 is equal to Q2 equal to situation. Now he says, remove, dielectric slab is removed, and the corresponding charges are Q1 dash and Q2 dash. Q1 dash, Q2 dash. Both are identical capacitors, right? Identical with this put. Now, C equivalent will be C equivalent into V. C equivalent is C by 2 into V. Now take the ratio. This is Q1 dash, Q2 dash. जो ratio चाहिए आपको वो ले. He's playing a cheap trick. These both are in series. Whether you have dielectric in between or not, both will have the same charge. Now 22nd question, by mistake it has come into capacitors. It has got nothing to do with capacitors, it's electrostatics. Gada majburi hai. Charge that must be placed at the center of the hexagon to make the whole system of charge in equilibrium. Net force on the particle at the center should be 0, and net force on
Yes, sir.
hexagon, right? Net force on this due to all the others should be 0. Nothing to do with capacitors, it was a mistake. Actually, while splitting capacitors and electrostatics exercises, it by chance was left over in the capacitor. Once upon a time, if you see, both the exercises of electrostatics and capacitors was combined first.
Yes, sir.
Sir, 25.
25. Fully charged capacitance C. It is discharged through a small coil of resistance wire embedded in a thermally insulated block of specific capacity S and M. If the temperature of the block is raised by delta T, potential difference across the capacitor A. Capacitor is discharged, right? So Q square by 2C or half CV square. जितना भी उसका initial energy है, that goes into ms delta theta. That's all. What is he asking for? Potential difference across the capacitor. Q is equal to CV. Q is equal to CV. Now have a look at it. V square is equal to 2 ms delta theta by C with a square root.
Okay.
All of the energy of the capacitor goes into ms delta theta.
सर डायमेंशनली भी एक ही ऑप्शन मैच करेगा.
मैंने तो डायमेंशंस नहीं देखा यार. अगर ये प्रॉब्लम डिफिकल्ट होता देन आई थिंक ऑफ डायमेंशंस. अभी जब इतना आसान है तो व्हाई विल आई थिंक ऑफ डायमेंशंस. इसका मतलब आप डायमेंशन कैलकुलेट किया. ओके हीट ना, हीट का डायमेंशन पता है, एनर्जी. ओके फेयर इनफ. पॉइंट टू बी नोटेड. The guy who solved using dimensions is the long-haired boy.
यस सर.
Now no more.
यस सर.
टेढ़ा सोचने की बहुत आदत पड़ गई इसे. बाल काटने के बाद भी टेढ़ा सोच रहा है.
सर बाल काटने से दिमाग थोड़ी ना चेंज हो जाएगा.
If your parents are at home, I would like to thank them. Do convey my regards to them. Thank them on behalf of me. I was also so very desperate to see you with a haircut. But I didn't need the lenience of telling you. But for that, I was wondering when will this guy get a haircut.
ओके सर, बता देता हूँ.
No, listen, not fair. No, by next week you will have even current electricity homework. In this exercise 2, 3, 4 are left over, which I see many have not done. Strength is going down already. It went down to 19. मतलब exercise 2, 3, 4 हुआ नहीं उन लोगों का. Giving them one last chance. Next Monday तक exercise 2, 3, 4 should be over. Please drop in a message in the group. Right? I will not be able to take doubts for you people in between because other sections evening I have lined up the other days. Friday I am free, but you people will be busy for a topic wise test. Preparing, not fair that I disturb you. Fine. Next Monday again 7 to 8. But you're piling up your doubts call workload. Someday I'll have to convert one of my regular lectures into doubts. So please don't do that. That will be wastage of time. Is that clear?
Yes.
HCV का कब करवाओगे? You people mean to say you don't have doubts in HCV capacitors? I'll be more than happy.
Sir, last
We
page there
have
are a few
doubts, sir.
HCV बगल में रख दिया आप लोगों ने. तो कल क्लास है ना हमारा, लास्ट हाफ एन आवर HCV का डाउट्स करें.
Yes, sir.
Can I leave that message in the group?
Yes, sir.
Please bring capacitors HCV doubts tomorrow to the class. Last half an hour I'll be taking the doubts of capacitors HCV. Fine.
Yes.
So see you people tomorrow. Next Monday I'll continue with exercise 2, 3, 4 of this booklet. Finish it off. Right? That next Monday I'll start current electricity doubts. You are on war footing. Better be prepared.
Yes, sir.
See you people tomorrow. Bye. Good night.